Now, we're moving on to volumes. Volume's all about how much space is inside a prism or a solid, okay? Not about the outside. If the question says answering capacity, that means they want your final answer to be in either liters, milliliters, or kiloliters. Anything to do with liters, okay? In order to know that, just remember, girls, 1 cubic centimeter is 1 milliliter, okay? So that's like 1 drop, okay? And 1 cubic meter is 1 kiloliter or 1,000 liters, okay? Now, in order to do that, we also need to be able to convert cubic millimeters to another. So let's get started. When we go from 1 cubic millimeter to cubic centimeter, first of all, we know there is 10 millimeter in 1 centimeter. And if we're looking at 3D version, see how there's 1 0? So add another 2 0. Okay, you're just repeating the number of zeros 3 times. That's how you quickly remember it. So for instance, girls, how many centimeter is there in 1 meter? 100. And because it's 3D now, you repeat the 2 zeros 2 more times. Okay, 1 2 1 2. Okay, so then now we have 3 of those same zeros. Yeah. So similarly, if we're going backwards, then it will be times by the same number on top, because you're going from bigger unit to a smaller unit. Okay. So you need to memorize that. Just have it in front of you when you do the exercise, but when it comes to the exam, that's how I memorize it, okay? So for example, girls, in this question, they want you to find the volume of the cylinder and its capacity in kiloliters. So let's find the volume. Now, volume in general is the area times height. What's the area of the top circle? What's the area of a circle in general? Pi r squared. Now, to find the volume, you always get the area times by the height. So that's your volume formula of a cylinder, which you've learned last year. So in this case, my radius is half of 128, which is 64. So that's pi times 64 squared times 241. Okay, so that will give me the volume in cubic centimeters. 3101179. I'll do it to 1 decimal place. Cubic centimeters. Now, they want us to convert this into kiloliters. So in order to do that, because we're in cubic centimeter, yeah, girls, I want to change it into that, because if I change it to that, that gives me what the question wants, which is kiloliters. Does that make sense? So change from this to this. So in order to do that, what are we doing to get from here to there? Yeah, divide by, is that a million? Yeah, million. Okay, so I'm going to divide that by million to change this into cubic meter. So divide that by million. So what's a quick way? Just move this dot 6 times, because there are 6 zeros. 1, 2, 3, 4, 5, 6. So it's 3.1 cubic meters, which is the same thing as 3.1 kiloliters, because remember, 1 cubic meter is the same as 1 kiloliter. Yep, so that's how you do it. Change the unit and then go to the capacity that you want. If they wanted you to convert this into just liter, what will I need to do with this?
Times by 1,000. Times
by 1,000, because there's always 1,000 milliliters in a liter, 1,000 liters in a kiloliter. So it's always by a factor of 1,000 to change from 1 milliliter to another. Yeah, does that make sense? All right, we want to do the same thing here. Find the volume of this. You always need to find the area of the front first, then times by the thickness of the solid. All right? So let's find the area of the front here. Obviously a composite shape, so I'm going to separate the front into 2 sections like that. So let's find the area of this bit. That's 40 times 12. That's easy. So I'll just write area for now. 40 times 12 plus the area of this rectangle is obviously 20 times 12. Okay, so if I do that quickly, that's right. That's 720 square centimeter. So the volume is 720 times. Girls, what's the thickness there?
15.
Yeah, 15 there, 15 there as well. Pretty obvious. So 1,800 cubic centimeters. Okay, the question doesn't specify what they want it in. So if they don't, just leave it like that. But let's say I wanted to change this into milliliter. What is it then? Have a look at the facts. Girls, we don't have to do anything. 1 cubic centimeter is the same as milliliter. Okay, so this is just the same thing as writing the same number again with just milliliter next to it. Okay, but then if I wanted to change that into liter, girls, if I want to change that into liter, what will I need to do with that? divide by, what's always a factor of 1,000. Divide by 1,000 if they want to change it to litre. Okay? All right, let's go through something similar here with a bit more working out to do. So we have to find the area of the front triangle here with a hole in the center. All right, how do I go about finding that? Let's find the area of the front. All right, so in order to find the area of the triangle here, girls, we know it's half times base times height, but we don't know what that height is. But we are given that. Can you see that? So girls, that's 26 as well then. I'll just do it in a different colored pen. That's 26. Yep. Girls, what I'm going to do once again, it's Pythagoras. Let's cut the triangle up like that. All right, so I need to find this y. So y squared is equal to, what am I writing? Oh, what's this?
21, 10.
That's 10, yeah? Half of 20 is 10. So 26 squared, what 10 squared? Minus, because we're finding the shorter length. So y is equal to square root of that, which is, all right, now let's find the area. So we know this is 24. So the area of the front triangle is half times 24 times 20. Not including the gap yet, the circle we haven't done yet. I'm just going to calculate this first. Okay. Now, area of the circle. So let's find the area of that hole. What is it?
4.5.
Pi times radius is 4.5 squared. All right. So if I do that. So basically the front area is that. Take away that. All right, let's find the volume straight away. So the area of the front, like you said, is 240, take away 63.6. And then to find the volume, we times by 60 because that's the thickness of the... Okay. All right, and once again, girls, listening. What's that in milliliters? Same number. Okay. That's basically what you need to know for this lesson.